All right, good morning, everybody. Hope you guys are doing well today. Today we are going to continue our discussion about systems of equations. We have in prior videos discussed linear systems of equations. We've also done nonlinear systems of equations where you graphed a line in a parabola or two parabolas or a line in a circle or a parabola in a circle, and we had to find the points of intersection. So those have all been two-dimensional equations as well as graphs. So what we're going to move into now is what would be considered three dimensions if you were to graph them. And the reason why they're three dimensions is there are three variables. And so as you can see in this first example here, there's an X and a Y and a Z. And I'm going to explain more about how that would look if we would graph it. We're not going to graph it, but if it were to be graphed, what this would look like and what a solution would represent. But for right now, I'm just going to show you how to solve a system like this, where we have an X, a Y, and a Z. And the first thing that I want you to notice about this is what we call row echelon form. So this right here, and I'm going to highlight a little bit. It should be, actually, it's a little tough for you to see the highlights. So let me circle it. I'll circle it in black. Row echelon form. That's how you pronounce that. And the row echelon form is a form at which we make our system so it's in this stair step pattern, as you can see. And if you look down at the bottom, there's only a z variable in the very lowest equation. Now, the next one up, there's two variables right there. There's a y and a z. And then the last, or actually the first equation, as we're working up, it would be the last. That equation has three variables in it. But the point of this is that it is in what we call row echelon form, and it kind of looks like a stair step pattern. That pattern is important, or this row echelon form is very important to be able to use the technique that I'm going to show you to solve this system. And that technique is called back substitution. Okay. Now, what back substitution is when you already know one variable and you work backwards with that one variable to find a next variable, which you can then use to find the next variable. It's almost like a snowball, right? So you start with one that gets you the next one, and then you can use those two to get the next one. That's what back substitution is. And you've actually kind of already done this before when you would solve these systems and you would maybe use elimination, maybe you use substitution came up with a value of one of the variables. Once you had that value of that one variable, you were able to take that value and put it back into the other equation and find the other value. So if you knew the x, you would substitute the x in to get the y. This is the same idea, but it's a little bit more involved because we have more variables. So, what I want you to key in on this is that we know, whoops, I didn't mean to cross it out. I wanted to highlight it. We know that z is equal to 2. So what that allows us then to do is to take this value 2 and substitute it in the next equation above. So I'm going to rewrite that equation y plus 3z equals 5 as y plus 3, but in place of the z, I'm going to put 2 equals 5. And then we're going to solve this equation. So we have y plus 6 equals 5. And when I subtract 6 from both sides, I get y equals negative 1. Okay, so now that we know what z is, you can see z is 2, and y, it's negative 1, we can then substitute those back in for the z and the y variable in the first equation. So I'm going to highlight z right here, which is 2, and then I'm going to highlight the y right here, which is going to be negative 1. And so when I rewrite this equation out, I get x minus 2 times negative 1 plus 3 times 2, and that equals 9. I ran out of room there. Now we're going to proceed to go ahead and simplify this equation. So we have x plus 2 plus 6 equals 9. 2 plus 6 is 8. And then we subtract 8 from both sides and we get x equals 1. And there's our third variable. So as you can see, we were able to solve for x and y and z. And what you get is called an ordered triple. An ordered triple is exactly like an ordered pair, except there's 3 instead of 2, and they are written alphabetized. So we will start with the x and we'll write a 1. Then we will write the y, which is -1, and then write the z, which is 2, like that. And our ordered triple, which is the solution to the system, is 1, -1, 2. And so what that was called, to reiterate, that is called we used back substitution to solve this system that was in row echelon form. It says the method of elimination can be applied to a system of linear equations in more than two variables. In fact, this method adapts to computers' use for solving linear systems with dozens of variables. And I will give you examples of that later on in Chapter 7, Section 1, which is the next chapter and section we go into. It says when using the method of elimination to solve a system of linear equations, the goal is to rewrite the system in a form to which back substitution can be applied. So what they are saying here is what I just showed you, back substitution, only works if the system is in row echelon form. And if you look at this next system that I have listed here, this system right here is not in row echelon form. You can see it's not in that stair-step pattern. So you can't use back substitution until your system is in that row echelon form. Do another back substitution problem. So again, start from the bottom. You can see z is equal to 3. We're going to substitute that in right there to that equation. And we're going to have y plus 3 times 3 equals 6. Y plus 9 equals 6. When you subtract 9 from both sides, you get y equals -3. So now we know what z is, and we know what y is. And it's just a matter of taking these two variables now and substituting them in for y and z into the first equation. So we're doing our back substitution. So it's 2x minus, and then the y value is -3, plus 5, and then the z value is 3, equals 22. We are going to simplify this, so it becomes 2x plus 3, and then plus 15 equals 22. Add the two like terms together. Subtract 18 from both sides, and then divide both sides by 2, and you get 2. So we get an ordered triple solution, and always list them in order. Make sure you alphabetize them when you list them. 2, -3, and 3. And there's our solution to that one. That's it for today. Have a great day.